Namaste everyone and welcome to Science Unfiltered. We are interested in drawing the loose dot structure of H2S, which is also known as hydrogen sulfide. Okay, maybe I'm just guessing that maybe in American textbooks the spelling of sulfur or sulfide is replaced by an F. Okay, so it is SULFFIDE. So if you're watching this from America, then please kindly adjust to this particular video. Okay, enough fun. Let's talk about the electronic configuration of sulfur. It is 1s2, 2s2, 2p6, 3s2 and 3p4. Now the electrons which participate in bond formation are the valence electrons. Now the valence electrons are the electrons which are present inside the valence shells or the valence subshells. Subshells are inside the valence shells. Okay, so what is our valence shell here? It is the third shell. Okay, and what are the valence subshells? It is 3s and 3p. Now in 3s we have got just a single orbital, whereas in 3p subshell we have got 3 orbitals. See these rectangular boxes. This is the first orbital, this is the second one, and this is the third one. Okay, yeah, see, and this is the electronic configuration. So 3s has 2 electrons, whereas 3p has 4 electrons. So I filled the 3p subshell with 4 electrons. Okay, now you guys can see that in 3p subshell there are 2 unpaired electrons, this one and this one. Okay, 2 unpaired electrons, which means that sulfur now needs 2 more electrons from other species, from some other species to gain stability after bond formation. Okay, so sulfur in its ground state, okay, sulfur is presently in its ground state, will make 2 bonds. This is clear. Now let's talk about hydrogen. See, the electronic configuration of hydrogen is 1s1 and its orbital diagram is simply like this. Okay, see, I told you for s subshells there's just a single orbital, where similarly in the case of hydrogen there's an s subshell. It doesn't matter for what shell it belongs to. Here it is from the first shell and here it was from the third shell, but it doesn't matter. What matters is that whether the subshell is an S, P, D, F and so on. So it is from the S subshell and it just has a single orbital. Okay, and it has 1 electron, so I have shown a single electron here. Okay, so here also we have got a vacant space left here, marked by the black cross. Okay, we have got a space left, which means that hydrogen needs 1 more electron to gain stability and to attain the electronic configuration of 1s2. Okay, this is a fulfilled this will be the fulfilled electronic configuration of 1s2 of hydrogen. And obviously I'm talking about after bond formation. After bond formation it can make the electronic configuration of 1s2, which is fulfilled configuration, and it is pretty stable, the most stable I should say. Okay, so it has just a single unpaired electron, 1 unpaired electron, which means that it will make a single bond. Okay, single covalent bond with some other species to gain stability. Okay, this talk was all about the basics. Now let's draw the structure of hydrogen sulfide. Okay, so our central atom is the one which is lesser in number. Okay, so we have got just a single sulfur, whereas hydrogens we have 2 hydrogens. So our central atom is going to be sulfur. Okay, sulfur, I have drawn sulfur. Now I just shown you that the number of valence electron for for sulfur was 3s2, 3p4. 2 plus 4 is 6, which means these are the valence electrons for sulfur. Okay, so drawing the valence electrons for sulfur, it is 1, 2, 3, 4, 5 and 6. Okay, it has got 6 valence electrons and it will make 2 bonds. Okay, and hydrogen's electronic configuration was 1s1, which means it has got just a single valence electron. Okay, so I'm going to draw the valence electron for hydrogen. Now I told you that hydrogen will make a single bond to gain stability and to attain the electronic configuration of 1s2. So it makes a single bond with sulfur. Similarly, this hydrogen will make a single, it's pretty far. Similarly, this hydrogen will also make a single bond with sulfur. And now let's count the number of electrons for hydrogens. Okay, so it is 1 and 2, so it has gained its stability 1s2, or in other words we also say that it has filled or completed its duplet. Okay, DUPLET, duplet. Now let's count the number of valence electrons for sulfur after bond formation. So 1 2 3 4 5 6 7 8. Okay, now 3s2 3p4 was before. Now it has got the electronic configuration of 3s2 3p6. Okay, the maximum number of electrons in a p subshell is 6 electrons. So sulfur has done that, it has done its part, and it has completed its octet. Okay, or it has gained a fulfilled electronic configuration, or has reached the maximum stability. So this was all about the structure of hydrogen sulfide. Thank you for watching, and I'll see you guys in the next video. Namaste.